Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today, we are diving into a race that could define the future of our planet, locking away carbon dioxide before it locks us into a dangerous climate. While cutting emissions is vital, scientists are increasingly sounding the alarm. Even with the fastest decarbonization, legacy coal will linger in our atmosphere for centuries. That's where carbon storage comes in, an evolving set of technologies designed not just to capture carbon, but to trap it permanently in the Earth's crust, oceans, and even our building materials. Why is this so important? Because carbon dioxide isn't a short-term visitor. It sticks around, warming the atmosphere for hundreds, even thousands of years. The Intergovernmental Panel on Climate Change estimates that to stay on track for net zero, we'll need to remove up to 20 billion tons of coal annually by 2050. That's not just cutting what we emit today, it's dealing with what we've already dumped into the sky. So, how are we doing it? One of the oldest and most proven methods is geological sequestration, injecting coal deep underground into porous rock formations. Think of it like putting carbon in a vault. Norway's Northern Lights project is already storing over 1 million tons of coal each year under the North Sea, with big plans to scale up. Canada's Quest facility has quietly stored over 7 million tons since 2015. These operations are built on the same science that kept oil and gas trapped for millennia. Still, the process isn't flawless. Seismic shifts can cause leaks like what happened in Algeria in 2021. But newer techniques, like Iceland's CarbFix project, are making carbon leak-proof by turning it into solid rock in just 2 years. That's science meeting permanence. Meanwhile, others are taking carbon and turning it into building blocks, literally. In mineralization, coal reacts with minerals like magnesium and calcium, forming rock-like substances. Startups like 44.01 are doing this in Oman's peridotite-rich landscapes, storing carbon at just 50 per ton. In the concrete world, companies like Carbon Cure and Solidia are embedding coal directly into construction materials. With over 700 plants already on board, this method is locking away hundreds of thousands of tons every year and making buildings part of the solution. Nature, too, plays a powerful role. Biochar, a charcoal-like material made from organic waste, not only stores carbon for centuries but also improves soil health. And restored wetlands and peatlands act like giant carbon vaults, soaking up millions of tons. Scotland's Flow Country alone holds the equivalent of 1,000 years of the nation's emissions. But these natural systems are fragile. Wildfires in Indonesia's peatlands released more carbon than entire industrial sectors. Then there's the ocean, an often overlooked frontier. Researchers at the University of Texas have developed a method to form carbon hydrates, ice-like solids using just seawater and magnesium. These can be stored safely in deep-sea sediments, where cold and pressure keep them locked away for thousands of years. It's faster, cleaner, and doesn't rely on rare chemicals. Pilot projects in the Gulf of Mexico are already testing the potential for global use. And ocean farming startups like Running Tide are sinking kelp to the seabed to sequester carbon naturally. But none of this works at scale without smart design, robust monitoring, and real investment. The U.S. Inflation Reduction Act now offers 85 per ton of coal sequestered, a huge incentive for the private sector. Projects like Occidental Petroleum's Stratos could soon be the world's largest direct air capture facility, and AI-powered satellites from companies like Sleipner are now watching carbon vaults in real time, tracking leaks, migrations, and ensuring that storage is truly secure. Equity is also a growing priority. In places like Kenya and India, low-cost, nature-based solutions are helping communities earn carbon credits while building climate resilience. It's proof that carbon removal doesn't have to be an elite, high-tech club. It can also lift economies and ecosystems at the same time. The message is clear. We are no longer talking about carbon storage as a theory. It's now a growing ecosystem, spanning science, industry, policy, and nature. From concrete to kelp, from deep rock to ocean sediment, CO is being transformed from a liability into a legacy. The decade ahead will be critical. Can we scale these tools in time to make a real dent in climate change? We have the science. We have the incentives. Now, we need the will. As one geologist in Iceland put it, we are not just storing carbon, we are rebuilding Earth's geological clock. The question is, can we reset it before time runs out?